Today's focus will be on the states of matter and the phase changes that they undergo. The three states of matter are solid, liquid, and gas. Solids have particles that are close together and they just vibrate in place. Notice that they are still moving, but they're just kind of vibrating back and forth. Liquids are particles that are close together, not as close together as solids, but they are close together, and they flow past one another. And then gases are far apart and they move quickly and randomly. One thing I want you to know about solids is that they, no matter what container they are in, they maintain their shape and volume. What that means is that if I put, let's say, a stapler in a cup and then I move it into another cup, it will still maintain its same stapler shape, and its same volume. It doesn't matter that I change it into a new cup. Liquids, on the other hand, will maintain their volume but change shape to that container. So if I have some Kool-Aid and I pour in one container and then I pour into another container, it's still going to be the same amount of Kool-Aid, but the shape will take the shape of the container. And then gases, they change shape and volume of the container. So whatever container it's in, it's going to take up that amount of space, and it's going to take up that shape of the container. All right, so let's try to sketch some particles. These are called particle pictures. First off, you're going to have to identify what type of state of matter it is. So fruit juice is going to be a liquid, and then helium will be a gas, and then ice will be a solid. So we're really asking for particle pictures like that. I like to draw like at least between 9 to 12 particles. I think it does a really good job. So for a liquid, how you want to draw a particle picture is all you do is you draw a squiggly line, okay? And then you draw the particles. I'm going to draw 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that they're random. It's not orderly. That way they can just flow together or flow over things, okay? Gases. Gases take the entire shape of the container and they're extremely spread out. So for gases, I actually like to draw less particles. So for them, I'm going to draw maybe like 3 particles for that same amount of volume. In solids, they're very compact and they maintain their shape. So I'm going to draw their 9, but they're going to be touching one another. They're not going to take that shape of the container. And make sure that also that you're touching the bottom of the container because of gravity. It's not going to be floating. All right, so here are some common changes of state of matter. So you have to identify what type of state of matter they are. And so we have our solid, our liquid, and our gas. This right here is a cover so that the gas does not escape. That's what it's implying. Okay, so when you go from a solid to a liquid, I personally like to think of the state of matter, I like to think of water and try to identify those terms because I think we're very comfortable with ice and water, and then it is gas as steam. Okay, so I think it's easy for us to be like, oh, when it goes from a solid to a liquid, what is that called? So when it goes from ice to water, what is that called? So that would be called melting. When you go from a liquid to a gas, that is called evaporation. You can also think of vaporization or boiling. Both of those are fine too. Gas to a liquid would be condensation. So you see it condensing, like when you're taking a shower and you see the condensation on your mirror when you've taken a hot shower, that's condensation. And then you also have freezing when you go from a liquid to solid. That's what your freezer does, is it freezes things. All right, so let's sketch a particle picture of the scenario below. So this is ice melting. So in order to do this scenario, you need to know a few things. First, you need to know how to draw particle pictures. And then the second thing you need to do is you need to be able to identify what is melting. So melting is when you go from a solid to a liquid. So my before has to be a solid. So I'm going to start with my 9 particles as a solid. Every solid for me in this class is going to look the same. Okay, you're going to have it looking kind of like a square. They're all touching, that type of stuff. After, it's going to be a liquid. So I'm going to draw my squiggle line. I used 9 particles in my before, so I'm going to use 9 again. I didn't lose any of my particles, so I'm going to have 9 afterwards. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. I do like to try to make them a little bit random, so it's not as orderly as that solid looks like. All right, there are 2 types of phase changes that you may or may not be familiar with, and they're not as commonly done, but some things absolutely do them. So one is sublimation, and sublimation is when you go directly from a solid to a gas. There's actually no liquid phase. Now this is at a certain pressure. like atmospheric pressure, which is like what we're at right now on Earth. You can change pressures and then it will possibly go through a liquid phase, but certain things at like room pressure and things like that will undergo sublimation. So there actually is no liquid phase. One that you're very familiar with is actually dry ice. Dry ice does that. You'll never have something that's a liquid when it's on Earth, right, at normal atmospheric pressures, where dry ice does not go from this solid to a gas. Then you also have deposition. Deposition is when it goes from a gas back to a solid without actually going through the liquid phase. Iodine does this, and so does dry ice if you could cool it down to enough of a temperature. But both of them will skip that liquid phase at atmospheric pressure. So let's just try to draw some of iodine. There is a really cool video that you should watch that is attached to this playlist. But let's try first off sublimation. Once again, it's really important to know what you're going from and what you're going to. I think that's the hardest part of the battle. So we are going from a solid to a gas for sublimation. So it's subliming. So a solid, then it's just drawing a solid. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then a gas makes up the whole container, 4, 5, 6, 7, 8, 9. Okay? And then deposition would be the opposite. Deposition is when you go from a gas straight to a solid. And so you go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's make it a little bit more compact to 9. Okay, so here's my gas, here's my solid, here's my solid, here's my gas. All right, phase changes in with regards to temperature. So temperature is the measure of the average kinetic energy. So it's not of any individual particle is the temperature, it's the overall average of all the particles. That's when you take your temperature, it's giving the average amount of all the particles, not of just one particle. The higher the temperature, the higher kinetic energy. And how do we measure kinetic energy? Kinetic energy is based off of movement. So what it's saying is that the higher the temperature, the higher the movement, meaning they're moving faster. Okay? When a substance changes from one state to another, the energy involved is either absorbed or released, and the particles become more or less attractive. So what you want to do is you want to think about this. Okay? So if I have a solid, okay, let's just talk about some energy. If I have a solid and I'm going to melt it, so I'm going to make it into a liquid, right? How did I get going about doing that? I think I drew too many particles. How did I go about doing that? How do I go from a solid, so let's say ice, to water? What has to happen? Well, the solid has to absorb energy in order to go to a liquid. That's why if you put ice outside on a hot day, it will melt pretty fast because it's able to absorb that energy pretty fast. Okay? And then what's happening is if you look at the particles themselves, if you look at the attraction, look at how attracted these guys are in the solid. They are right next to each other. Look at this liquid. They're not as attracted. You have more distance in between them, right? You have this distance. So you get less attraction as you go up. So which one has the most energy or associated with it, or which one has, I guess the most energy would be your gas has your most energy. The least energy would be your solid. How do I know that, or how could I logically figure that out? Well, in order to go from ice to, let's say, boiling water, right? I have to, like the gaseous part of that, I have to add heat. So which one had to have more energy? Well, gas did, because I had to add energy in order to get to that gaseous state. All right, so this is another image of that. So whenever you are melting, you are adding heat. Just think of the sun. And then whenever I am trying to go from liquid to a gas, I'm undergoing vaporization or evaporation. I once again have to add some heat to go to that. So to go the opposite, you just have to take away heat. So to take away heat to gas, you're going to go from a gas to a liquid, you're going to be taking away heat. That's why you put things in the freezer, right? Or a refrigerator. It cools things down. It slows those particles down even more. And so a liquid to a solid where you put it into the freezer or you're freezing it, you are removing more and more heat. Same thing goes when you're subliming. You're going from a solid to a gas. Obviously, solid has less energy than a gas, so you have to add heat. And then when you're going from a gas to a solid, gas has more energy than a solid, so you have to remove heat. All right, hopefully you have a basic understanding of the three different phase changes. I mean, the three different phases and then the phase changes that they can undergo. Have a great day.